We are discussing about feed-forward networks now, and in feed-forward networks, we're having a backpropagation networks. So, what is a backpropagation network? It is a supervised learning algorithm for training the multi-layer perceptron, or we can say to train artificial neural networks. We use backpropagation networks, and that is a backpropagation neural networks. So, why do we need it? Right? What is the need of backpropagation network? Why we are studying it? It's more so let's do a study that. See, while designing a neural network in the beginning, we initialize the weights, right? We always initialize the weights as we have studied in a unit, right? We initialize the weights with with any random values or any variable for that effect, right? Now, now, obviously, we are not a superhuman. Like, so it's not necessary that whatever weight values we have selected will be correct or it fits our model the best. We don't, but we are saying that first attempt, for example, we are sending a weight to a network. It doesn't mean that it will give us the desired output, right? We are a human being, we perform it, we do it, hit and trial, and after maybe at sixth, seventh, or we don't know at what step we will able to get it correct, right? We will get the correct value of weight. So, what happens actually? How we will get the best value of the weight, so which finds our model, this we will get after some trials, right? So what they are saying that we have selected some weight values in the beginning, but our model output is a way different than our actual. So we have selected some weight values in the beginning, but our model output is a way different than the actual output. This is known as an error. So every time when we are not able to fit our values with the output, it means we are getting some error, right? And we are here to reduce that error. We have a number of methods to reduce that error. You have must have studied in the other subjects, right? The very famous one is a gradient descent method, in which when we got the minimum error, that error we have to take, right? So we are not saying that the error will be zero, but we are saying it will be the minimum after a time, after uh, a small interval of time, it will be the minimum. So we will take that as the final weights, and we'll consider that it will be the best fit model, and we are going with that much weight. Okay. Now, basically, what we need to do, we need to somehow explain the model to change the parameters such that the error becomes minimum, right? That we have already told you, because this is one of our tasks here. We have to minimize the error, right? Now, let's put it on another way. We need to train our model. On way to train a model is called a backpropagation curve, right? So what we have a model with us, we got the error, we find out whether it's a minimum. If it is a minimum, then it's okay. We go and take it and use it for the prediction and for the future. But if it is not a minimum, we have to again update the parameters and we have to train the model. We have to keep on training the model until we get the minimum, right? So this is the first step in a backpropagation neural network we have to mention, right? Now, what next we have is the backpropagation network. Now, how it works? How it works, we know it very well. We have a network like this. This is the input layer we have, and this is the these are the hidden layer. We may have any number of hidden layers in our network, and here in this particular network we have a two hidden layers, hidden layer 1 and hidden layer 2, and this is the output layer, right? So all the nodes are connected, all these input neurons are connected to all the neurons of hidden layers, and further the neurons of hidden layers are connected with the other neurons of the hidden layer, and then those are connected with the output layer, right? And these are known as your back propagation output layer. These, right? The neurons of output layer and the neurons of the last hidden layer, right? So we'll keep on working on the algorithm that we have till we get the minimum error, right? Now, what the definition says. Definition again says that a backpropagation algorithm is neural network computes the gradient of the loss function for a single weight by a chain rule. It efficiently computes one layer at a time. Unlike a native direct computation, it computes the gradient, but it does not define how the gradient is used. It generalizes the computation in the delta, right? So this is the diagram we have, and this is the algorithm that we are going to follow it. We have an input X arrived through the pre-connected path. Input is modeled using the real weights W. These are the weights at all the neurons that we have taken out, taken here, and these are the randomly selected weights we have taken. Calculate the output for every neuron from the input layer to the hidden layer to the output layer, right? So we will be calculating the output, right? We will be calculating the output. We know the formula of the output very well. It's the multiplication of the weights and the input, right? And after that, we will calculating the error here. The actual output, what will the actual output and what is the desired output? We will be taking the difference of that and we'll getting the error, right? After that, travel back from output layer to the hidden layer to adjust the weight such that the error is decreased. Keep repeating the process until we get the desired output, right? So this is the way how this algorithm is going to work, right? So this is what we have in a propagation neural network. Now, what are the other steps we have in the backpropagation network that we need to study? So we have to calculate the error, how far is your model output from the actual output. This we will be getting with the error calculation only, right? So we'll be getting the error in this way. What next we have? Being a minimum error we have to get, right? Our aim is to calculate the minimum error and we have to check whether the error is minimized or not. This we have to do. What next we have? Update the parameters. We have to update the parameters, and if the error is huge, then update the parameters, weights and the biases we have to update, right? If we're getting any error, we have to update it. If we're getting any error, we have to update the weights and we have to update the bias. In this way, we have to go, right? After again, we have to check the error. We have to repeat the process until we get the error minimized, right? Now, what next? Next, the model is ready to make the prediction. If we have able to build a model with a minimum error, it means we have achieved a fitted model with us. And once the error becomes minimum, it means we can find some inputs to our model and that will be going to produce the best output, right? So this is what we have here in this. Now again, what the algorithm is saying and what its meaning is, we have to train the model in such a way that it will be getting a minimum error function we have to find out, and with the help of that we have to find out the solution of a learning problem, right? So this is what backpropagation network we have with us. We have to find out the error. We have to keep on finding out the error, calculating the errors, and we have to keep on doing it that way, right?